Here we are reacting a weak acid with a strong base. Our balanced chemical equation, we have HNO2 that we express as HNO2 because it's a weak acid and the vast majority of it remains undissociated. It's going to react with hydroxide because that's what we have when we put NaOH in solution. Products are going to be the conjugate base of the weak acid plus water. We can write our BCA table. Initially, we have 4 millimoles of our weak acid. We're adding 1 millimole of a strong base. We initially don't have any of the conjugate base, and this is a liquid, so it does not matter to our equilibrium. All of our strong base is going to react and consume 1 millimole of our weak acid. So we have 3 millimoles of our weak acid remaining. We don't have any of our strong base, but we have generated 1 millimole of our conjugate weak base. So this is a buffer solution. We have a weak conjugate acid-base pair in solution. Again, that's a buffer, so we can solve this via Henderson-Hasselbalch, where we have pH is going to equal pKa plus log the concentration of our base over the concentration of our acid. Okay, now as we've discussed, the ratio of the concentrations of the base to the acid is the same as the ratio of the moles in solution. Substituting in, pH is going to be the negative log of the Ka of our weak acid plus the log of 1.0 to 3.0.